Hi, this is Mr. Max. So I'm doing paper 2 of 2022, the AS level. So we're going to look at a few questions. So for this part, I'm going to do questions 1, questions 2, questions 4, and questions 9. All right, so I'll be doing this question paper in 3 parts. All right, so make sure that you are familiar with the instructions as far as the examination is concerned, especially with the degree of accuracies that you are supposed to follow. If the answer is not exact, you give your answers to 3 significant figures. And when you are dealing with angle sizes in degrees, it's 1 decimal place. But angles in radians supposed to be given to 3 significant figures unless you're given a different level of accuracy in the question. And let's get right to it. So I'm focusing today on on questions 1, where you are supposed to solve this equation, which is an absolute value equation. The absolute value of 3x minus 1 equals to 4. And the thing about absolute value equations, you should remember that you should always check your solutions in order for you to make sure that you the solutions checks out. Okay, so you will have to create 2 equations where you have 3x minus 4 equals to 4 and 3x minus 4 equals to negative 4. Think of the absolute value as a distance. All right, so this is a linear equation that is very easy to solve, so that gives you 8 over there. So this is supposed to be 3x minus 1, just to make sure we don't make that small mistake over there. So we're going to have a 5 over here, and x will be 5 divided by 3. And the other solution, you'll have 3x equals 2. So you have negative 4 plus 1. So that gives you about negative 3, giving you that x will equal to negative 1. That is if you were to divide throughout by 3. Okay, so you can quickly check your solutions just to make sure that both of them work. So I'm going to substitute. You can do this obviously with a calculator in the exam. So you're going to have 3, and in brackets I have 5 upon 3 minus 1. So this obviously gives you 4, and obviously the absolute value of 4. So this solution here checks out, and then you can obviously go back and replace this value over here. All right, you replace it with negative 1, so that gives you negative 3 minus 1, which is like negative 4, and the absolute value of that is 4. So this solution also checks out. Okay, now let's get to part B. It's now saying hence, so you are supposed to use your answer, what you got in part 1. So if you were to look at the equation in part 1, it was 3x minus 1 is equal to 4, and this 5 raised to the power of y is now going to equal to the answers for x. And in our previous answers, we had 2 solutions for x. We had that x equals to 5 over 3 and x equals to negative 1. So we therefore have to say 5 raised to the power of y is equal to 5 over 3, or 5 raised to the power of y is equal to negative 1. Now, here's the thing. You are now supposed to use logs. It doesn't matter which one, so I'm going to use taking logs both sides. Now, here is the problem with the second instance. So you have got log 5 raised to the power of y equals to log of that is a constant. But for this one, it will obviously not work because you can't take the log of a negative, does not exist. Okay, so the only solution we're going to focus on would be this solution over here. All right, so you can go ahead then and say, okay, wait a minute, y equals to log 5 over 3. You divide that by log 5. Okay, so you can grab your calculator for that and you can work it out. So you say log 5 upon 3, you divide that by log 5, of course that gives you 0.317. So y equals 0.317 3938055. Okay, and then you just give your answer then to 3 significant figures because the answer is not exact. So you say therefore y equals to 0.317. Okay, that's the final answer. Right, question 2, I've highlighted it here as well, so we're going to do question 2 as well. Solve the following equation. So anything that you have got e raised to a power of something, remember it's going to definitely involve you to take the natural log somewhere. Okay, so we're just going to rewrite this as 2e raised to the power of x and squared, because it doesn't matter how you write the indices, it still give you the same. All right, so 17 e raised to the x plus 8 equals to 0. And you can perhaps say, let e raised to the power x be replaced by some k. So that gives me 2k squared minus 17k plus 8 equals to 0. Okay, then obviously you can use the formula in order for you to find the value of k. So this is going to be something that involves you to use your calculator. Just do the correct substitutions in here. So this one here will be 8, and everything should be over 2 times 2. Because remember, if for an AS level student, you should be identifying your A as 2, your B value as negative 17, and the C value as 8. Okay, and then you just substitute it in there. All right, so that will give you 2 solutions. If you go for the first one, k is going to be equal to 8, and the other one, k will be equal to 1/2 if you were to solve that. Right, but remember we had e to the power x is equal to k, so I'm going to replace this k with e to the power x equals to k, and the same over here, e to the power x equals to k, equals to 1/2. And then they are saying you are supposed to leave your answer in a certain way. All right, so one of the things you should know is that the natural log, which is log base e of e raised to the power of x, which is log base e of 8, and you should know that log base e is nothing but the natural log. Okay, so this is going to be x. If you bring over that, log base e of e is just equal to 1. Right, so just so we can write it in the required form, this is natural log of 2 cubed, and then x equals to 3, the natural log of 2. Okay, because they said you must leave your answer in x equals to a, where a is a constant, times the natural log of 2, and in this particular case, it's 3 natural log of 2. So in the second instance, again, I'm just going to say x equals to the natural log of 1/2, which is x equals to the natural log of 2 raised to the power of negative 1. Therefore, x equals to negative 1, the natural log of 2, which is also a solution, which is in that form, the required form. Okay, right, so that takes me to question 4 of the same paper. So I'll get back to the other ones in the other parts. This one deals with polynomials. They are given 2 polynomials, f and polynomial g, and they are defined by f of x equals to x cubed plus ax squared plus b, and g of x is equal to x cubed plus bx squared minus a. So they have given you a x plus 3, they say is a common factor, or is a factor of f, and x plus 1 leaves a remainder of 6 for g. So that means that if you have x plus 3 as a factor, then x equals to negative 3 can be used, and you're going to say into f you put negative 3, all right, everywhere where you have an x, you replace it with that -3, and it is a factor, so it's going to equal to 0 if you do that. So this is nothing but -27 plus 9a, because -3 all squared is +9, plus the value of b gives you obviously naught. So at the end of the day, this is 9a plus b equals to 27, which could be your first equation if you have to look at it like that. This over here can be my first equation. Then for g of -1, doing the same thing, you take obviously x plus 1, let it equal to 0, then x equals to -1. Once you insert that, there is a remainder of 6. So into g, everywhere you have an x, that is -1 cubed plus b times -1 squared plus a, no, but it's minus a. And that leaves a remainder of 6. So go again, you can go ahead, this is -1 plus b minus a equals to 6. So at the end of the day, this is b minus a equals to 7. Of course, I will just maybe use a different method here. I will say b equals to a plus 7, and that would be my second equation. Right, the objective is to do substitution. So I'm going to substitute this equation in here into the first equation where I have a b there. Okay, you can use either method of substitution or elimination in order for you to find those missing values. So that gives me 9a plus, now I have a plus 7 should equal to 27 if I do that. So that's 9a plus a plus 7 equals to 27. So that's 10a equals to 27 take away 7. 10a equals to 20. That implies that a equals to 2. Now, in order for us to find the value of b, we simply substitute in any one of the equations. I'll be using this one, so I'll say b equals to our a value, which is 2, plus 7. Therefore, b is equal to 9. At the end of the day, the solutions then are a equals to 2 and b equals to 9. When a and b are these values of 2 and 9 respectively, find the smallest possible value if you take g of x minus f of x. Now, let's just have our g of x. Our g of x now is going to be x cubed plus 9x squared minus 2. Okay, right? Remember from our work before what our g of x was. So we now just substitute those values that we've calculated for b and for a. We're going to take away f of x, right? And I'm just going to put this in a different color coding to help you navigate through. So it is x cubed plus 2x squared plus 9. So if you are subtracting the x cubed plus 9x squared minus 2 minus x cubed minus 2x squared minus 9. An interesting thing happens is that the x cubes will definitely cancel, and it leaves you with 9x squared take away 2x squared, that is 7x squared, minus 2 take away -9, that's minus 11. Now here's the thing, the smallest value occurs when x equals to 0. Therefore, you're going to say 7 and you put a 0 in there, minus 11. So the answer, this question, is -11, the smallest value. All right, that takes me then to our last question for this part, which is question 9. So let's go all the way to question 9 in the question paper. Question 9 I've highlighted here as well. All right, so another question on logs, you have the function f is such that f of x is equal to 2 log base 2 of the quantity x minus 3 for the domain x must be greater than a certain value. And here's the thing, you know that the logs of negative numbers cannot exist, so you can't have the first order of business. You'll be saying the stuff inside here, x minus 3, should be greater than 0. Okay, and if that is the case, then that stuff should be obviously greater than 3. Therefore, our value of a that is required is 3. Then they are saying find an expression for the inverse of the function. So let's just write the function as y equals to log base 2 of x minus 3. Then obviously you are going to swap the letters around. Hope you still remember. So this is going to become x equals to log base 2 of y minus 3. So the concept here is for you to make y the subject of the formula. So we're going to write this in exponential form. So that becomes 2 raised to the power of x is equal to y minus 3. So the inverse then is going to be 2 raised to the power of x plus 3. That is going to be the inverse function. Okay? And you don't leave your answer in terms of y. Now they want you to find the range of the inverse. And here's the thing that you need to understand. The domain of f of x is equal to the range of the inverse of x. So we know that the domain was x is greater than 3. Therefore, the range we are looking for should be nothing but y is greater than 3, because we must give it in terms of y. Okay. Then they say for part C Roman 1, the function g is given. So g is given as 3x take away 2. I just have to rewrite it over there. And then you have to take the inverse of f, which we know as 2 cubed plus 3. And we're going to substitute into g everywhere where you have an x value. Okay, so that implies that it's 3, then it's 2 cubed plus 3 minus 2. And we just sort of clean this up on the calculator. So you can grab your calculator. So that gives you 3. That is going to be 8. Let me just clear my calculator so it can be, the display can be exactly appearing as it would otherwise appear as I was to write it down. So plus 3 minus 2. Okay, you hit enter, you get 31. So the answer here is 31. Then they say show that f of g of 1 cannot be evaluated. So let's see what we have. Remember, we know that g of x is equal to 3x minus 2. Okay, and if you put 3 and put 1 into that, you're going to get an output of f of 1. And if you were to put this f of 1 into our f of x was log base 2 of x minus 3. The part that I want you to pay attention is this part over here. And if you were to put this value in here, it will generate a negative number. So it will be something like log. Now let's just use the correct. So we say f of 1 then gives you log base 2 and f 1 minus 3, which gives you a negative value, and it's not possible. Okay, so you can go ahead and say the domain, which we know the domain of f was x should be greater than 3, and in this particular case you realize that it is not the case. Okay, so therefore it's impossible. All right, now as I said, I'm dividing the paper into 3 parts. This was part 1 of 3 of this question paper. Okay, stand by for the others.